This is 6.1, a new chapter. We're going to be talking about triangles and angles. So first, just as a reminder about the definition of what an angle is. An angle is two rays connected with a common point, a vertex. And so you have a common point, and you have the initial side and the terminal side. Remember, terminal means ending, so you would literally go from here to here. And so that's what an angle is. Also, just to clarify this, we mentioned this earlier, but you have a degree symbol. Look on this next picture, you have a degree symbol marked theta, and the measurement, this angle that it measures, angle, whatever angle that is, the measurement of the circle is a radian measure from the angle. Okay, so if I was only opening up a certain amount compared to a certain amount, the measurement makes all the difference in the world. So, that's what a radian is based off of the angles. All right. So you should remember this as well, how to convert degrees to radians. So you already know that 360 degrees is 2 pi. So obviously 180 is 1 pi. And if you do a little division, you can get 1 radian is basically 180 over pi. And you can convert radians to degrees and degrees to radians by simply just multiplying by that fact, all right, to be able to do that. So let's look at some more definitions, and then we're going to be doing some converting here in just a minute. So standard position, we already talked about. You start with your initial side, and then you go to your terminal side. And so this is what's called standard position. The vertex is at the origin, and the initial side is on the positive x-axis. So I can also, these are all 3 examples of what standard position is. So here I have the center at the origin, I have the initial side, and I have the terminal side. Even if I go counterclockwise or counterclockwise, either way, that's my terminal side. Well, the same thing here. Again, I have a standard position starting at the origin. The initial side is on the positive side, and I'm going to go around the circle several times. I'm still ending at this. This is still the terminal side, but I went around the circle 2 times, 3 times, 4 times. It doesn't really make a difference, but this is still the terminal side. All right, so coterminals were 2 angles that are in standard position and they coincide with one another. So look at example A. So example A, both of these terminal sides are the same. So if I went 50 degrees, this is approximately 50 degrees, or if I went negative 310 degrees, they both end at the exact same spot. So they are both literally coterminal. And the same thing here, I can have 2 pi over 3. This measurement here is 2 pi over 3. And then I can literally do the exact same thing as 8 pi over 3. So in other words, if I just kept going around and add 2 pi to it, then I would get to 8 pi over 3. I could add another 2 pi, and it would be the exact same thing. I could literally go around the circle and just add 2 pi, add 2 pi, add 2 pi. It's kind of like if I went 50 degrees, and then I went, if I went 360 degrees around, so 410 degrees is also the same thing as 50 degrees. It's also the same as negative 310 degrees. So really, to get a coterminal side, you're just going to add 360 degrees, or in this case, subtract 360 degrees to be able to do it. Or if it's in radian mode, you're going to add 2 pi to it, or subtract 2 pi to it to get to the next coterminal side. So here's an example. It says find a coterminal angle of 1290 degrees. You could draw a unit circle if you want and go 1290 degrees around until you get to 1290 if you want. But basically, remember, a coterminal angle is the exact same angle, the terminal angle where it ends at. And again, since it's in degrees, that means we're going to be basically taking 360 degrees. And normally what I want is a coterminal angle within the first circle. So literally, but in this case, the directions don't say. So I could literally, if I wanted to, I could subtract 360 degrees if I wanted to do this, and then get 930 degrees. And so this is the exact same coterminal angle as 1290. And if I subtract 360 360 again and subtract 360 again. I can, this 570 minus 360. So all of these, I can keep subtracting 360 because 360 degrees is the exact same thing as one complete revolution around the circle. And I can keep subtracting 360. I mean, just literally keep subtracting 360. Or at the very beginning, maybe instead of subtracting, I could have added 360. You know, to do this. And so all of these are coterminal angles from 1290. They're all coterminal. They all end in the exact same spot as the original one. So let's talk about length of the arc. So again, we referred to this at the very beginning. So the length of an arc of a circle is we're basically going to take r, the radius of the circle, times theta. And theta must be in radians. That's something you got to really remember to do, not in degrees. So here's an example. So I want to find the arc length of a 30-degree angle. So here's an example. I drew a 30-degree angle. And it has radius 10, and I'm trying to find the arc length, just that length. And I'm literally going to do it just by multiplying r times theta. Or keep in mind, though, the radius is 10. That's obvious, so I'm doing radius is 10. But theta must be in radian form. So you have to convert 30 degrees to radians. And from the unit circle, you should, I mean, you don't have to do this one because you should already know that 30 degrees is pi over 6. But if you want to convert it, remember you multiply by pi over 180, right? And that's going to give you pi over 6. So when you multiply this, you're going to get the distance of that arc, of that degree is 5 pi over 3. Now something I do want to mention to you, if you memorize the unit circle, 5 pi over 3, if you actually measure the distance of 5 pi over 3, that's literally all the way around like here. Okay, so if you measured 5 pi over 3 of a unit circle, that's different. But remember, this is not a unit circle. This is a radius of 10. So keep that in mind of the directions, because here the radius is different. All right, so let's talk about the area of a sector. So again, we're not talking about the measurement of the arc, but we're talking about the actual area inside of there. And we're going to use this formula right here. You should remember that from geometry class. So 1/2 r squared theta. So you're going to just follow the formula. And again, 60 degrees is the degree measurement, which 60 degree is pi over 3. If you need to convert it, just take 60 times pi over 180. Remember to convert it to radians. And you're going to get pi over 3. And when you multiply that out, that's going to give you 3 pi over 2 meters squared. And that's our first lesson, finding the angle measurements of a circle